It is now time to put the beast to good use. As robotics students, I always wanted to have personal projects to progress in this field that will one day be my professional life. Combining mechatronics with my current knowledge of software engineering seems to be the recipe to be able to create absolutely whatever the fuck I want. AI-driven robot dogs, automatic toasters, haptic devices, 3D scanned custom-fit dildos, and a whole lot more. But for that, I first need to learn a little bit more about product design, mechanical engineering, CAD softwares, measurements, just all of that good stuff. Well, what's a better way to start on these, for me, new processes than having a real-life first freelance mission for my family business and sponsor of this video, the Lagrange Teas and Coffee Company. Yes, this is a small YouTube channel. Yes, I still accept brand deals. Yes, I need to pay for college. And yes, you can insert your own opinion way deep down your ad. This video is brought to you by Lagrange Herbals Tea and Coffee. Being a cliché 21st century software engineer, I do have a crippling caffeine addiction, as well as being a coffee snob who pretends he knows what he is talking about. And Lagrange has a very wide selection of herbals and infusion references, as well as exceptional specialty coffees, roasted by Vincent Ballot, who got a title for France's best craftsman for his coffee roasting skills. Get your Lagrange order today delivered to your door anywhere in Europe. And use the code marius10 at checkout to get 10% off your next order on any Lagrange product. You can go in the video description to learn more. So I am working in this brand new building on the first floor upstairs with a Jeff Bezos view over the inventory. And since I have all of this space for free, not paying rent, just like your jobless cousin in your 20 square meters apartment in downtown, why not help that wonderful business with some sweet over-engineering shenanigans? So, showing off my brand new toys to the employees, my sister and salesman of this wonderful company asked me if I could help with a little logistics problem in the inventory. So, we sell tea, coffee, and infusions to simple customers just like you and I, also called caffeine addicts in need of a fix. But Lagrange also does some B2B oriented kind of stuff, selling these tea boxes presentation kits consisting of a big aluminum box, a see-through tester, and, I promise I'm getting to the point of this video, please don't click away, magnets with the product name, information, ingredients, and all of the good stuff written on the thing. Yes, I am flexing the fact that I have a tea with my own name on it, and you cannot do shit about that. Deal with it. Well, these magnets in inventory are stored in a not so optimized way. Every time you need to find an appropriate magnet, you need to go through all of those references, kind of knowing the color of the label, in hopes of finding the right magnet reference. Take one out and go about your day, losing a bunch of time every single time you need a different magnet. Multiply this problem to about 100 different references, and this adds up to a huge time loss. Look also at this not a static box in which they are. Just gross. We're talking like 20e arrondissement de Paris kind of gross. Nope. So, the idea was, starting from a storage cardboard box, widely used in the rest of the inventory, find a cost-efficient way of having the different magnets displayed and arrange so that you can see every single references at once, in alphabetical order, making it easy to grab one, restock, and all of that with a little bit of sturdiness. Because this ain't a fine watch manufacturer, it's a tea and coffee inventory. Gotta move. Gotta go fast. Looking for the big bucks down there. With that information, I bust out the calipers, my measuring tape, pulled up my pens, and it was time to get into the intricate world of product design. I started with the measurements and the modeling of the box, in which I needed to make the entire contraption. I needed to come out with a solution to create independent compartments that I decided to call mag holders for every single magnet reference for a set amount of magnets. I called one compartment a mag holder. Yeah, it's badass. I like it. First one to judge is not invited to my trademark party. Each magnet is 160 by 60 mm and 3 mm thick, which are some above average measurements, by the way. No issues with that. With consideration that we would not have more than 50 magnets per compartment, I now had a volume to build the mag holder around. After a few research about wall thickness recommendation for 3D printing with PLA, I jumped into SolidWorks, and it was a first time for me. But being an avid 3D software user and developer, SolidWorks was a breeze to domesticate, and I was an expert in absolutely no time. SolidWorks is nothing like any other 3D software I've used. It's like, imagine Blender, but like way more corporate. It's a bit like if Cinema 4D decided to quit its art major to go into law school kind of vibe. It's a bad analogy. It was hard, right? It was hard. But after a few tutorials here, one or two Tylenol's there, I came up with an award-winning design. Ladies and gents, mag holder V1. Honestly, just don't say anything. I know. It looks like dog water. There obviously are some progress and upgrades that can be added to this design. And here were the observations. The insert is way too snug. I would like to be able to be less surgical when it comes to insert the thing inside the thing. The manufacturing process of the magnets makes it that the sheet comes with a bend, meaning it flops around in the holder. We need a better way to maintain the entire structure inside. And that small lip in the front, just like a 50-year-old angry conservative Twitter account, doesn't have any purpose. That entire backplate can be optimized in terms of materials it needs during printing. And just like you're watching, that bottom doesn't need that much attention, printer material-wise. It's a butt joke. It worked way better in my head while we're writing that one. One good thing we can take away from this design, though, is that 2 centimeters extra length at the tip, that I would absolutely love to have myself. That is the perfect amount of extra material to display the reference name and color code. Well, based on all of those reviews, notes and new data, here is the MHV2. We got rid of the front lip and inserted this big extrusion here to maintain the bend of the magnets inside of the holder. We rounded out those sides for both and extra support, and also added those holes in the back to be able to save some more material, because daddy is a cheap ass. We have this triangular 40-degree pattern at the top so that the printer doesn't have to print over direct emptiness. And based on some research I did, 40 degrees is safe enough.
Oh, but why are you showing us the SolidWorks model? And not the print itself? It seems absolutely perfect. Why?
That's why. This design, just like Angela White on a busy business Wednesday afternoon, absolutely sucks. The back plate of the V2 was a disaster to print, and even before it had time to finish, I had to stop and pull out before disaster happened. See what I did there? I am severely sleep deprived, but before directly going back to the drawing board, we can make some observations. Starting with this front part, what I decided to call the shtick tension detention system is way too thin and flimsy to serve any purpose. We'll have to find a way to make that way more sturdy. Sturdier? Sturdier? More sturdy? Sturdier? Is sturdier? No. The back design obviously also needs a review, but the bottom hole seems to be the right dimension for those big boys. The boys being the magnets. Cannot believe I am the one writing those things. So, with those, back to SolidWorks, and here is V3. I mean, see, it looks good, printed okay, doesn't look as material heavy. The cost is approximately 83 cents worth of material per mag holder. Back design looks great. I mean, we can call it the final design, right? Well, just like a lot of you gym noobs out there trying to hit the 4 plates deadlift, the back is way too soft. Like McDonald's play strength playing too soft. This joke was shamefully taken from Michael Reeves' content. Michael, if you're watching this, I love you. Please notice me. Also, in the front we decided to go double shtick tension detention system for double the fun, but those are too soft as well. Also, the magnets that we are designing the MH4 are the newer dimensions, and we still want the design to work with the older, smaller magnets too. And this hole at the bottom is way too big to handle for those smaller fellas, which is absolutely okay. Happens to the best. So, conclusion from the V3, we need better support for both the back... Oh, Jesus. We need better support for both the back plates and the double STDs, as well as a new bottom hole. And this is how the MHV4 is born. The side curves were brought back all the way to the top, adding a lot of sturdiness. The double STDs have been reinforced with some ribs, and we added one extra support at the bottom for smaller magnets. And it works just fine. Perfect. Easy clap. Let's now talk about the mounting system. Oh, no. No. It would have been too easy. Until now, apart from a few smooth-brain design choices on my end, the printer never really was a bottleneck in the workflow. Until the moment I discovered the wonderful world of first-layer adhesion. My printer is what we call an FDM printer. For fuse deposition modeling, filaments of hot plastic, in this case PLA, are squirted out by a fuse on top of each other to create the 3D shape that you want, meaning that the new layer of plastic relies on the previous layer to stick and stay in place. But how about the very first layer? Gotta stick to something, right? Well, that first layer is responsible for the entire part itself. If the first layer gets unstuck from the printing surface, the entire part goes bye-bye and you just ruin some sweet PLA. Well, this is what my smart ass thought.
I mean, a piece of steel is a piece of steel, huh? Plastic goes sticky on the surface, everything is fine, huh?
No. I ruined 2 35-hour printing batches because of that. It was at this moment I learned that having a really clean bed, and even help the first layer of adhesion with PBA glue, was a thing. It also means that the bigger the surface area of the first layer, the better the part is going to stick and stay in place. This is also why I added thickness to the added bar in the bottom hole to add more surface area on the MHV 4.1. And smooth brain time again. It was only after printing a 40-hour batch of 9 mic holders that I discovered that this tiny modification put the whole bar and the double STDs out of center. God, I love my brain. I fixed that last little issue, reconsidered that back pattern for more printability, and boom, V4.2 baby. Solid enough, not looking half bad, sturdy, printable, it's perfect. We got the Mac holder, we got the box. Well, now it's time to find a solution to prevent this from happening. I wanted to create a sort of grid to go at the bottom of the box to hold the array of Mac holders in place, while neatly separating them at a regular interval. A little bit like Zach Friedman's Gridfinity project. By the way, Zach Friedman, Voidstar Lab, good YouTube channel, great YouTube channel. Zach, if you're watching this, love you, dude. Love you. So as I said, a little bit like the Gridfinity project, but with a bit more of a permanent fit. And as you can imagine, seeing how much of a nightmare... Oh Jesus, what is wrong today? Seeing how much of a fucking nightmare was to develop the Mac holder, developing the grid matrix was an absolute disaster. Everything went well. No rage, no printer catching on fire, no nothing. Done the research for what a good tolerance would be for a PLA tight fit. Apparently 0.1mm is enough. Made a test piece, worked like a dream first try. Patterned the test piece in a 3x3 and a 3x2 matrix. For a total of 24 insertions per inventory boxes. Press fit the Mac holders in, and boom. We got it. Even with the problems encountered during development, that project was an absolute banger to work on. This is room temperature coffee, okay. Oh, the headache. I have learned so many new things. Got to finally create a product from start to finish entirely by myself, and also helped a company that is obviously really important to me. It's a new skill unlocked, and boy oh boy, we gotta have fun with that in the future. Guess it's time for the cliche, usual YouTube stuff. Okay. If you like this video, do not forget to like and subscribe. We do a bunch of shit related to tech and not so tech stuff. I often work on different projects live on stream, where I can interact live with you guys, answering your questions, or react to your cringe, very cringe memes and jokes. Keep them coming though. You can also follow me on every single social media ever. It's usually at marius.ballot or marius.ballot, marius.ballot in the baldy old language, where I often give updates on the different projects I am working on, answering DMs, and connect with you guys for potential collabs, reviews, or just saying hi. That is it for me. Thanks for watching, and talk to you very soon on the internet. Promo code marius10 at checkout, the best cup of coffee on entire life. I can guarantee it. Okay boys, bye bye.